Hello viewers, today in this video we are going to start the new chapter Laws of Motion, and in this chapter we have to first of all introduce few basic concepts. So let's start. I will try to show you here one basic animation. You can see here itself. As you can see here, a car is moving, and from your previous knowledge of various chapters, maybe motion in the straight line or motion in the plane, you have learned what is the meaning of motion, right? So a basic question comes to our mind that what is the cause for the motion of a car? What factor may be behind the motion of the car? Obviously, that is a beautiful question which can come into the young minds. We will try to answer this question. But before that, let us try to introduce some basic concepts which are required here for this chapter. The first is inertia. This you will find in the beginning of this chapter itself. So what is inertia? How it is defined? So it's very simple. We can define it is the tendency of an object to be in the rest or to be in uniform motion. Be careful about this fact. What we are defining inertia? Inertia as the tendency of an object to be in the rest or to be in the uniform motion. Let's introduce one more factor here, okay? And the factor is here momentum, okay? The question comes that how to define the momentum or how it will be useful to understand the concept of the momentum. So let me introduce here again. So momentum can be defined as the product of mass and velocity of the object, that can be called as the momentum. It is a simple quantity which is referring to the product of the mass of the object and velocity of the object. So mathematically you can write here P is equal to m into v, where m is the mass and v is the velocity. There is a beautiful question for you. What is the meaning of, or what is the SI unit for this quantity momentum, and what dimension we can write for the case of momentum? So I think that there is no need to talk about the SI unit if you know once what is the formula for the momentum, right? And easily you can estimate dimension also. So let's go for the next point. These are the two important things that we have to understand here. Now, let us try to introduce about the Newton's laws of motion. We will take one by one, okay? So basically there are three laws, okay, which we are calling as the Newton's first law or law of inertia. The second is the Newton's second law of motion or law of momentum. And the third, very important, I think everybody know about this, right? And that is the Newton's third law of motion, or it can be called as the law of action and reaction, okay? So we have to go one by one for all these three laws. So let's begin with the first law, okay? So what is the first law of motion and how it can be defined, that we have to discuss here. Let us try to understand this concept here, okay? So what is the statement for this, that we will first of all discuss here. So first law of motion states that an object will remain at its state of rest or uniform motion unless until it is acted upon by an external unbalanced force. This is very important. To change the state of an object, we have to apply, what we have to apply here? We have to apply external unbalanced force. Let me give some examples to you. There are multiple examples, but I will start with some basic one which you have learned in your elementary school also. That famous experiment already you have discussed. Coin and the paper is kept on the glass, and then coin is kept on the paper and paper is suddenly take out. So in that case you will find that the coin falls in the glass. It is something like this. So this already you know, okay? This experiment already you have studied, okay? You can see here, clear cut. So if suppose I toss that paper, the coin will fall down in the glass. So basically we can say that the coin want to stay back at its previous position when the paper is sliding down or sliding away. that time that coin do not want to go along with the paper and it will just fall down. But here one more argument can come, that always the coin will fall down or whether the coin can go along with the paper also. It may go along with the paper also, but there are different conditions for that. So that we are not discussing right now here. Okay, so this is the first law. Let me give on again some examples to you. Turning of passengers in the bus. So suppose there is a bus, it is taking the left turn and you are shifting to the right like this, or if the bus is taking suppose right turn, then you shift to the left turn like that. So these are also the consequences of the Newton's first law of motion. And obviously moving backward or forward in the vehicle at the beginning or at the stop. Let us say you are sitting in the vehicle and say the bus is just starting, so you get pushed back like this. Okay, and similarly suppose the bus is in the motion and say the bus is suddenly stopped, you get pushed forward like this. So this is basically the consequence of the Newton's first law of motion. Let's dig into it again and let us try to understand the second law of motion. Okay, so for the case of second law of motion, we have the statement like this: the rate of change of momentum is directly proportional to the applied external unbalanced force. Many students answer about the first law of motion and third law of motion, but many fails to state the statement of the second law of motion. So remember it is the rate of change of momentum and it is directly proportional to the applied external unbalanced force. So mathematically, if I want to write down, I can write here F is directly proportional to dP by dt. In some books, you will find it as delta P by delta T also. No problem. And if I solve, I can write here F equal to some constant K dP by dt. But from the experiments or from the observations, it has been revealed that you can take this K equal to 1, then also there is no problem. So we can write simply F equal to dP by dt. So this is our second law of motion. Let us try to now take some examples based on the second law of motion. One more thing, if you put the value of momentum here, then this force turns to m into a also. Okay, this is also called as the second law of motion. Let me give the examples now here. You can see here, pushing a car and a truck. Okay, suppose you are trying to push a car, or if you are trying to push a truck, then which will change its momentum faster or larger, that we can understand. If there is heavier object, obviously you have to apply a lot of force on it to change its momentum or the velocity. Okay, second, hitting a ball. Many of you play the cricket. Okay, so that time you know that to change the direction of the ball, you just toss it, you just try to take the full toss, or you try to take it in different directions. So you are just giving the direction to it. It means that you are applying the force on that object to change the momentum of the object. Pushing a shopping cart, many of us, we are going for the shopping in malls or big bazaars. So that time we are using the trolleys to take the material with us or to take the articles with us. So when there is heavy load in our trolley, that time you will find that it is little bit difficult to take or to carry that trolley. So again, you have to apply the large force to produce the large acceleration, or say acceleration. Rocket propulsion is again one more aspect which is based on the Newton's second law of motion. Okay, and suppose there is a crash between two cars during an accident. If they are moving with more momentum, or say they are moving very fast, then they are imparting large forces on each other. So that time also we can see or we can observe the role of second law of motion. Now without delaying, let's go for the last law, that is third law of motion. What is it? Very famous statement, everybody know about this. What is that? Every action has equal and opposite reaction. So here action and reaction, these two terms, they are related to the force basically. Okay, so there are multiple examples. Say recoiling of a gun after fire. If you are firing a bullet from a gun, that time what happens? The that pistol or say that gun, it get forced back or it get just bounced back. It is called as the recoiling of the gun. Okay, so it is again due to the Newton's third law of motion. The second is horse and cart. Suppose a horse is trying to pull a cart. At the same time, cart will also try to pull the horse back. So there is also, we can say that the action and reaction is playing its role. Hammering a nail. Suppose if you are trying to just hammer a nail, if you want to pierce that nail inside the wall, you have to just put a lot of force on that nail. Why it is so? Because the wall is giving the reverse force or the reaction force, we can say. So to overcome that, we are giving the force. Your walk, we are walking or running, it is also based on the idea of action and reaction basically. Okay, so there are multiple examples for Newton's third law of motion also. So I hope that with this video you came to know about some basic facts like what is inertia, what is momentum, and what are the different laws which are called as the Newton's laws of motion. And at the same time, you might have came across about the idea about various examples where these Newton's laws are applicable. So here we will stop. Thank you very much.